And what's on the docket tonight? We've got, as I wrote to you, geometry. Before the break, after geometry, I'm going to do a little bit of preparing to face the GMAT strategy stuff that we didn't get to last week. Then after the break, Emily will do critical reasoning, strengthen and weaken, and sentence correction comparisons. So without further ado, let's get to geometry. So first, a couple of principles and methods of approach to geometry before we dive into our first problem. So, some principles, and I'm going to use this diagram over here on the right as a way of illustrating. So, the first principle is if they don't tell you something, don't assume it. So, what do we know about ABC here? Go ahead, type it in for all to see. What do we know about ABC here? This figure ABC with the straight lines. What do we know about that? Type it in for all to see. Good point, Ryan. In one sense, we don't know anything. But I will tell you that if you see a straight line, you can assume it's a straight line. It's not microscopically bent. So, Andrew, you're right. We can infer that it's a triangle. And then John Laurent mentions that B's angle is 90 degrees. Do we know that? Do we know this angle is 90 degrees? The answer is no, we don't actually know. Catherine brings up the point that within the triangle, the angles total 180 degrees. I'll come back to that point in a minute. But on Jean Laurent's point, we don't actually know that this is 90 degrees, even if it looks like it is. So do not assume that that's a right angle. Okay? But Emily brings up something similar to my point about the straight lines. Lines that look straight actually are straight. Straight lines that, or curves that appear to touch actually do touch. They're not that much jerks, so to speak. The second principle I want to point out is if they give you a piece of information, you're going to use it. It's very rare in general on the GMAT that you'd be given information that you don't need in order to solve the problem. Very, very occasionally happens, but by and large, you use everything that you got. And especially on geometry, you should sort of force your way forward. If you're stuck on a problem, go ahead and see what you can compute. Now, if we tell you that this is a circle, that the round thing around triangle ABC is a circle, which they would say, and if we tell you that segment AC is a diameter, not just any old chord of that circle, but an actual diameter, then you can actually infer Jean Laurent's point, which is that ABC is a right triangle. That's just a property of a triangle inscribed, as they say, in a circle. If one of the sides of that triangle is an actual diameter, then yes, indeed, the angle opposite that side is 90 degrees. So if they told us that we were dealing with a diameter there, we'd be all set. Third general principle, you just got to know the rules. You don't want to be re-deriving, what's the area of a circle? Is it 2 pi r or is it pi r squared? No, you just got to know it, okay? Last thing you want to be doing on the exam is trying to sort of re-derive rules like that. So this rule, for instance, that a triangle inscribed in a semicircle is a right triangle, is where one of the sides is the diameter, is one of those rules to know. How important is that rule? Well, it shows up in the problem here and there. There are other rules that may be more important, such as the one that Catherine brought up, that all the angles within any triangle add up to 180 is a critical rule. You just have to know that one. You don't want to be re-deriving it. Any questions on this? Text them in. Let me also go through a couple of points about a general approach to geometry problems. The first thing is geometry is visual, so you have to make sure that you diagram. Either redraw the picture that they show you on the screen or draw it from scratch. Sometimes they'll just describe something, as we'll see in a few minutes. So make sure you draw it on your paper. Second, you should add information from the text. Sometimes they will be actual numbers, such as the length of such and such a side is blah blah, or it just might be labels, like this is point X, that's point Y. Could be areas. It could also be that things are the same, and so mark the things that are the same, either lengths or angle measures, with slashes. Could be that two things are parallel to each other. Mark those with arrows. Make sure that you get the information down that's given to you in the text. Now, when you draw your picture, what happens often is that you say, I'm going to run out of scrap paper, so I'm going to draw it real small here in the corner. No, draw it big and precise. Now, they give you diagrams that aren't to scale. They could be drawn a little differently than they're given to you, but you should try to have the visual work for you, not against you. You don't have to be an artist. Don't take too much time on your diagram, but do try to make it work for you, not against you. Next, you identify the thing that they are asking you for. So is it a length, whatever it is, an angle, and you should make sure you label that wanted element on your diagram. The way you're going to label it is with a variable typically. So this is just like a word translations problem in which you name the thing you're looking for, X or Y or A or whatever it is. So make sure that you do the same thing here. And finally, you should make sure that you infer from the givens. Now there are a couple of different ways to do that. They will give you relationships. They will sometimes say the area of this rectangle equals the area of that rectangle, in which case you can write an equation equating the area of one and the area of the other rectangle. Sometimes, though, it will be more of an inference or sort of a new role for the thing, and that will awaken another part of geometry for you. So let me give you an example from the previous page. Type into the direct message window, what is AC? What is AC? What role or roles does it play? What is AC here? Please type it in. Fantastic. I'm seeing already AC, the length AC, plays two different roles in this diagram. One role is that it's a diameter of this circle, and therefore it's twice the radius, therefore it's opposite a right angle, all those things. But Andrew points out that it's also the hypotenuse of this right triangle. So frequently the more complicated geometry problems have this sort of turnabout of roles in which something, some length, say AC, is both a diameter and a hypotenuse. It has a role in the sort of circle, in the circle club, and it has a role in the triangle club. So often these inferences that you have to make revolve around not just putting down the rules and the formulas and writing the relationships and solving the equations, but it's often around those sorts of double roles or even triple roles that things play. I'll just say again, know your rules. Any questions before we go on? All right, let's get right to it. First problem, you've got 2 minutes. I'll put the timer up and go ahead and start. Okay, that's 2 minutes. Give it a shot. Okay, people seem to like the odd numbered letters, A, C, and E. Cool. No one wants B or D. So what I'd like you to do is take your laser pointer. Remember, your laser pointer looks like the little exploding firecracker. And I want you to put it on a piece of information given to you that will then put into our diagram. I'm assuming that you've redrawn the diagram on your own piece of paper. Go ahead and use the laser pointer and put it somewhere up here on a piece of information that we'll put into the diagram. All right. I think, Brooks, you put laser pointer on CE equals DE. Do you want to jump on and tell us how we'll put that into our diagram rather than just copy it down?
What I did is I just drew a line through the middle of CE and DE, just one like slash mark through there to show that they were equal.
Fantastic. Give me a smiley face if CE and DE look equal to you, or give me a thumbs down if they don't look equal to you in our drawing. Yeah, heck no, they do not look equal to me. So when you see a piece of information, and I'll switch back to the laser pointer and make mine the finger up here, the pointer finger I should say, they don't give you the other choices for other fingers. They don't just write down CE equals DE. You want to turn it into a slash, just like so. And then you have to trust those slashes. Don't trust your eyes. So let me ask you, Brooks, what can we then infer from that bit of information?
From that I would infer that the angles underneath those lines would also be equal to each other.
What do you mean by angles underneath those lines? Use your laser pointer and point to them. Fantastic, exactly. It's the angles, as I often use the term, opposite those sides that are equal. It's not the ones that look equal. They're not going to look equal. Look, this is a pretty narrow angle here because this side is pretty short. This is a pretty big angle in reality in what we see because this side is pretty long. But we have noted down that these two sides are the same, and therefore these two angles are the same. Now, you do have the choice when you redraw this. You could force those two sides, CE and DE, to be the same. And that is a totally good tactic to take. It's a little scary, though, because your diagram will look different from the diagram on the screen, and that might throw you. Okay, so let's get some more information down. Point to some more information, everyone. Use the laser pointer. Someone's on 45. Whoever that is, jump on the mic.
That's me again. So I put down 45 for Y in the angle there.
Cool, you're fast with that laser pointer. Exactly, it says 45 with the little degree symbol, or if you just have a keyboard like me, you're typing in degrees. So now let me ask, what can we do? Ryan, what can we do next?
What you can do next is, since you know y is 45 and you know the other two angles are equal, so you can take 180 minus 45, and that gives you 135 degrees, and then you split that 135 degrees equally between the two angles, so each remaining angle is 67.5 degrees.
What does everyone think? Smiley face or give a confused face to that? Or claps? Or exploding fingers? Awesome. So 67.5, you could write that by saying, oh, let those equal angles be z or something like that, and then 2z plus 45 equals 180. Fantastic. That's applying Catherine's rule of 180 degrees that she wrote up earlier. We see it right here in the very first problem. Catherine, since I brought you up, bring us home. There's something we haven't used yet, and we are not yet there. So what do we do?
The statement above states that AB is parallel to CE, so you can draw a symbol. I usually do an arrow on each line to show that they're parallel. And then, given that they're parallel, and then the line BD is crossing both of those parallel lines, then you can determine that the angle X equals angle ECD, which is 67.5.
Great. So tell me again about X and 67.5. How do we know that they are the same?
Since AB and EC are parallel, and the line BCD is crossing those two parallel lines, then you know that the similar angles will equal one another. I don't know the true definition, but that's how I think about it.
Fantastic. That's exactly right. Sometimes what you have to do in order to see what comes about as a result of parallel lines, which is what this symbol up here between the AB and the CE means, and I noticed that Emily has put it in. This here says that those two segments are parallel to each other. Sometimes what I do is extend the lines also so that I can see them a little bit more clearly. And I extend also, it's technically called the transversal, this line in magenta. And then I see that corresponding angles, such as X and the 67.5, are the same. So the X degrees and the 67.5 degrees, exactly the same. So our answer indeed is 67.5. So notice there are several different ways to approach this based on which piece of information you start with first, but we're going to wind up in these geometry problems using everything that they give us. We used the y equals 45 degrees. We used the fact that these two lengths are the same. We slashed them down. That tells us. Does anyone know the term for a triangle such as CED that has two sides that are the same? Type it in if you know it. Yes, awesome, isosceles. And it actually is technically, when you go to a spelling bee, put in an extra S. It's actually technically spelled, and this is just so you know, for that spelling bee, I-S-O-S-C-E-L-E-S. The GMAT is never going to care. Do not worry about that. That's geek lore. So notice I want to show you on this next slide that if, I'm going to just remove a whole bunch of, show you a bunch of things here. If you did draw this to scale, this is actually what it would look like. CE here and DE or ED are the same length, and I've drawn them in red, but drawing that on the fly might be a little sketchy to do. So my tendency would be, I'm drawing it just as they showed it to me, then I'm going to get down the information with slashes and so forth, and I'm going to follow out what that means. And the fact that this angle Z here is 67.5 and it doesn't look like that, who cares? So any questions before we go on? Okay. Here is your next problem. I'm going to erase what I just drew there. Go ahead. Okay, 2 minutes. Give me your shots. All right, seems to be a lot of consensus in the class. I won't say what that consensus is yet. To give you a little hint here with the 3D drawing. 3D problems are pretty rare on the GMAT, but when you do encounter them, it's important to be able to draw them. And the way to draw a box, just to go through it, is draw a rectangle, then make a copy of that rectangle. Obviously, you can't do it quite the same way when you are drawing. Then connect the 4 corners, which I'm doing now in magenta. And you have a box. I actually had a student who had a particular issue with drawing 3D objects, so I just want to walk through that. Sometimes also I want to say when you're drawing 3D, you want to draw 2D versions of the same thing. We'll come to that in a second. So what do I do now according to my process? Razi, jump on the mic.
What's the greatest? I'm going to draw a straight line between the greatest possible. That would contain the greatest possible distance between any 2 points, and in a rectangular box, that would be from. Let me see. I'm thinking about laser pointer from right that corner to this corner. That would be the greatest distance, and in order to get that calculation, we just use a formula that's been given. I can't remember what the name was. Is it something Pythagoras, but there's an addition to it, and that just states that if we call that line B, we just say d squared is equal to the length squared times the width squared times the height squared. Plus d squared equals so 10 squared plus 10 squared plus 5 squared. And then we just solve for d, which ends up being d squared equals 225, and d equals 15.
What do y'all think? Smiley face, confused face if you didn't totally follow. All right, there's some agreement, and there's some question about that because the deluxe Pythagorean theorem, as Catherine refers to it, is pretty advanced. So let's see if there's another way to do this. That totally works, and I'll go ahead and say you are correct. But let's see if there's another way in case you've forgotten this deluxe Pythagorean theorem. Anyone try this another way without squaring up all the different pieces, the 10, the 10, and the 5? Everyone did it deluxe? Yeah, Brooks, jump on.
Well, I couldn't remember the deluxe one. I knew it was out there, and I couldn't remember if it was adding or multiplying or whatever, so I wound up doing it the long way, and taking the length times the height, and finding the hypotenuse by doing the Pythagorean theorem, and then taking that times the width, and then doing the Pythagorean theorem with that to find the diagonal of that triangle that went through the inside. So I did a two-stage Pythagorean theorem and didn't realize what the deluxe one was. It was adding, just like was said.
Totally fine. And if you do it in two stages, you can do it as sort of a couple of different ways. One way is, I imagine actually standing. I'm a little dude standing here in the room. And I'm imagining I got to get from the corner I'm standing in, with my blank face there, I got to get from here up to there. And if I know this deluxe Pythagorean theorem, I can say it's 10 squared plus 10 squared plus 5 squared equals d squared, true. Or what I can do is I can say I'm going to cross the floor and get to the other corner, and then I'm going to go up. And crossing the floor is a matter of crossing the diagonal of a square. So I say 10 and 10, and what is this diagonal of a square? Type it in if you know the diagonal of a square whose sides are length 10. What would be the diagonal there? Type it in so all can see. Awesome. It's the side times square root of 2, and you can get that either from a 45-45 90-degree triangle or from Pythagorean theorem saying 10 squared plus 10 squared equals c squared. I prefer that you can directly write that c winds up being 10 times root 2. And then you plug that back in to the second Pythagorean theorem, where 10 root 2, this blue line, is one leg, 5 is another leg, and d is the hypotenuse of that big triangle. So shown it here, going from opposite corners just slightly differently shown. 10 root 2 is our diagonal across the floor of the room, which turns into the leg of the other triangle. Notice again here we have something that I alluded to before. We've changed roles. This 10 root 2 is, on the one hand, the hypotenuse of this bad boy, of this triangle, or the square if you want to complete the whole thing, of the floor. But then that turns into just one leg of the big triangle. Again, a sort of change of role. I also want to say, sometimes folks think the square root of 225 is 25. You should note here that there's no way that 25 could be the right answer, because if we go, let's say, over 10, then 10 in yet another direction, and then up 5, we could not be 25 inches away. We would have to lay that 10 and that 10 and that 5 in a straight line to be 25 inches away. Seeing Danielle's question, would the answer change if we labeled the sides differently? It definitely wouldn't. It would just turn the box around, and we wouldn't have to find this 10 root 2. It could be you found, what I think Brooks, you did, was find another face diagonal, as it would be called. But you've got to get the same distance for D overall. So notice this is a pretty high numbered one. The point again I want to make about 3D is that when you draw it, if you're having trouble, say, seeing this 10 root 2 in the floor here, simply redraw. Just draw part of the picture. And that's, in general, a helpful trick. We saw that in the first problem. If you don't see how to apply this these parallel lines, you might actually extend the lines and see, oh yeah, what I have is I have a transversal. I have a line crossing two parallel lines. Same thing here. By redrawing the picture in a way simplified, you can sometimes spot what it is that you need. Any other questions? Also want to point out 10 root 2 is an answer partway there, and 10 root 3, does anyone know where 10 root 3 would come into a problem like this? Go ahead and type in. Any 10 root 3, where would that come in? It could come in a 30, 60, 90 triangle, in an equilateral triangle, but specifically in a box. Where would 10 root 3 come in a box? Anyone know? Exactly. Razi's got it right on. The diagonal of a cube in which all sides are of length 10 would give us a diagonal of 10 root 3. So if we weren't in a 10, 10, 5 box, but in a 10 by 10 by 10 box, then in fact the diagonal would be 10 root 3. Let's go on to the next problem. Any further questions on this one? Okay. The formula for the diagonal, the sort of body diagonal of a cube. Let me go ahead and write that. The body diagonal of a cube where you cross completely through the middle. If one side of the cube is S, then the body diagonal is S times root 3. Okay, next problem. Again, you've got 2 minutes. Go ahead. Okay, that's 2 minutes. I'm going to give you 45 more seconds. Keep working if you haven't gotten to an answer yet. And if you have gotten to an answer, see if there's a different way in which you could solve this problem. Go ahead. That's 45 seconds. Roshan, could I ask you to come on the mic and get us started on this problem?
Well, first I saw that it was, I drew the diagram first of all, and then I quickly noticed that there was a 5 and 13, so that reminds me of 5, 12, 13 triangle. And then based off that, I could actually create a rectangle and a separate triangle based off the 2 and the 12. And then from there, I had a rectangle and a triangle, a 2 by 12 a rectangle, and a 5 by 12 triangle. So that's how I kind of got where I was.
Cool. Let's do that in 2 stages. First, you saw that this distance here, AB, was 13, and this was 5. And again, if it helps you to redraw quickly without the extra lines, you might say, you know, that reminds me of a certain type of triangle. And Roshan said a 5, 12, 13 triangle. That's awesome. It's a common Pythagorean triple, as they're called, a series of 3 numbers that could be sides of a right triangle. And you can always rederive what x is. For instance, you could say 5 squared plus x squared equals 13 squared, and go ahead and prove that x must be 12, or even better, just know it, because that'll save you time. So now that we've got that 12, Roshan, get back on the mic and describe what else you did. You somehow cut this up in pieces. Can you show me using your laser pointer first where you cut up this rudder? Show me with your laser. Cool. Actually, that's awesome. That's even better. So get back on the mic and describe it, and I'll type some things on the board as you do so.
Well, once you cut it over there, you have a 2 by 12 rectangle, and you then have the other side, which is 5 minus 2, a 3 by 12 triangle, which you can just kind of do the math from there. 5 times 12, 60, 6 divided by 2 is a 3 by 12 divided by 2 is 18, and then you have an 18 by plus a 24, and you got a 42 right there.
What do y'all think? Smiley faces, confused faces? Okay, I'm seeing some smiley faces. I'm seeing some folks that might not have gotten it that way. Let me tell you, you're absolutely right. So first, the lower half of this cut up rudder is a rectangle. 2 feet by 12 feet, so we got 24 feet. That's the easy part. Then we still have a 12-foot leg here, and this would be 3 feet, 5 minus 2. And then the area of this guy, as long as we have a right triangle, which we do, by the way we drew it, then we have 1/2 times 3 times 12, which gives us 18, and then 18 plus 24 equals 42. Raise your hand if you did it in a different way, in some fashion. Yeah, Ryan.
The problem stated that it was a trapezoid, so to me it looks like it's a trapezoid that's kind of been flipped on its side from what you would normally see. So that means you can just plug it into the trapezoid area formula, which is base 1 plus base 2 times the height divided by 2. So if you take 5 plus 2, which is 7, times 12, which is 84, divided by 2, that yields 42.
Fantastic. So since they told us it was a trapezoid, that says to us that these two lines here are parallel. We could also see that because there are 2 right angles here, and that means that this line and this line are going to be parallel. And I loved what you said. This is not the usual way that you would see it. You'd often see the 2 parallel bases, as they're called, set horizontally. But here the rudder is set vertically. But you could simply turn it on its side, or simply say, okay, these are the 2 bases, and this 12 here is the height. Either way, the formula then becomes, the formula for the area of a trapezoid is a nice to have. It's the sum of the 2 bases divided by 2, which I'll just type in here for a second, and then we multiply that by the height. The way I think of this is it's the average of the 2 bases. In fact, you can prove this formula either through Roshan's method, which is a way to prove the area of a trapezoid, or you can cut it up slightly differently and think of moving just sort of the top part of this rudder over here and making a rectangle with 3.5 feet sides. The way I think of the trapezoid formula is it's a nice to have. It's not as fundamental as the area of a triangle or the area of a rectangle. The area of a trapezoid is a nice to have for two reasons. One, it's not going to show up as frequently. And two, you can always get around knowing it by doing what Roshan did, which is slice this thing up into two pieces and get it done plenty fast. But if you do know it, then it will speed things up. So as you review your rules and formulas, you might think priority as well. The trapezoid area formula is pretty nice. It's not as fundamental, though, as the area of a rectangle or the area of a triangle. So did anyone figure out this length up here? Give me a smiley face if you figured out this length from basically this top corner to here. Nope, no one did. Good. Because you can figure it out. Turns out to be some nasty square root. It doesn't do you any good. So a further point I'd like to make on this is don't figure everything out that can be figured out. Sure, it's a nice to have, but it's actually distracting. So don't figure out every single thing that you could. So just to recap again, it's handy to know some of the common right triangles. The most common is, of course, the 3, 4, 5. The 5, 12, 13, here it is, showing up in a real GMAT problem. Again, we've got the two roles where on the one hand, we have the 12 as a leg of a triangle, of a right triangle that we figure out using Pythagorean or the 5, 12, 13 common Pythagorean. But then it quickly becomes the height of a trapezoid, or conversely, the side of a rectangle and the base of yet a different right triangle. So again, we have the 12 here playing this sort of pivotal role. It's changing roles. There are a couple of other ways you can do this, but I think these two are the fastest two ways. On to the next problem. Any other points, questions? Okay, here is your first data sufficiency of the night. Yep, they show up in geometry as well. So you got to bring everything to bear. Everything you know about data sufficiency plays out in geometry as well. Here you go. 2 minutes. Okay, take a shot. Whether or not you're comfortable. Come on now. Okay, so text everybody. What's the first thing that we do here on this here geometry problem? What do we do? Text everyone. Yes, thank you, Danielle. So we draw a diagram. And it doesn't have to be pretty, it just needs to be approximately representative. So we got to draw it. Now, text privately to me and Emily what this blue highlighted text means in math language. Oh, did I switch these up? Oops, I sure did. My fault. Thanks, Ryan. So, thanks for the save. So, what does that mean? The length of the edging that surrounds circular garden K. And later on they tell you that the edging has negligible width. So here from above, you wouldn't see it. Yep, you're typing it in. It's circumference. So this distance here, if you kind of even need to draw your pen around it to kind of see it, oh yeah, that's the distance around a circle. So they're giving us some piece of information that connects the circumference of K to the circumference of G. And we should type that down somewhere. So circumference of K equals 1/2 the circumference of G. What can we do with that, Danielle? Go ahead, jump on the mic, Danielle, and tell us what we can do with that piece of information. Or anyone. Go ahead, jump on. Raise your hand if you want to contribute. Okay, Dinesh, go ahead.
If you know that the circumference is related, you need to use the circumference formula, which is 2 pi r equals the circumference. And given a relation, the first, second, so we have the two circumference equations equal to each other, and one thing is 1/2 the value.
Yep, 2 pi r of garden K equals 1/2 2 pi rg. And now what can we do? We did have another mic fade there. Let me see who I'm going to talk to. Angela, what can we do at this point? This isn't the most beautiful of equations here. What can we do with that? Got the knack tonight for cold calling people. Sorry about that. So, Amit, what can we do at this point?
You can determine the ratio of the radii, and then based on the radius, we can determine the area.
Yeah, so what are we asked for? Type it in, everyone. What is it that we are asked for in this problem? Type it to all so that everybody can see it. Go ahead, type it in. What are we asked for? Yep, we're asked for the area of garden K, which is a circle. And since that's pi times the radius of K squared, what we're really asked for exactly is the radius of K. And Danielle's got it nailed. Because of this relationship here, since RK is half of RG, the true rephrasing when you incorporate the given information is what is the radius of G. So notice how much we've done in a sense to get that. So this is really all about rephrasing the question. The initial question is just what's that area, and so we rephrase it to what is RK, but that's not really the interesting part. When we draw the pictures, and we should always be thinking with circles, go for the radius, go for the radius. As you noted before, the length of the edging is the circumference, and once we put that relationship together, put it down, we have the radius of K is half the radius of G, and so the true kernel here is what is RG. And so now we look and we say, okay, that's a heck of a lot easier. If they give us the area of G, that gives us the radius. If they give us the circumference of G, that gives us the radius as well. Really, all four major dimensions of a circle are all intertwined. You know one, you know them all. You know the radius, then you know the diameter, you know the circumference, all of which are lengths, and you know the area, which is an area. I also want to point out that if you got stuck on this one, there is a sort of trick to narrow it down on a problem here that only applies every so often. But if you got stuck up here, you said, man, I'm running out of time, I got to do something, and you jump to the statements, and you see, you know what, those statements are telling me the same thing. They're telling me exactly the same thing. This is giving me the area, which means it gives me the radius, gives me all that other stuff. This is giving me the circumference, it means it gives me the radius, all that other stuff. They are the same information fundamentally. Then what are my possible answer choices? Type them in so everyone can see. If the two statements are essentially identical in what they're truly telling me, what are the possible answers? It's actually D or E. It'll never, you might think it might be C, but it's actually not. If the two statements are identical, it would never be C, although it seems like, yeah, it would work together, but really it's neither one would work on their own, so it's got to be D or E. Either they each work, or not even together will they work. And of those two, it's more common, I would say, that the answer would be D. So that would be my guess here. But the geometry point is rephrasing all the way from all this stuff takes us to what is the radius of garden G. And then it becomes relatively straightforward. Okay, a couple more. We'll go to coordinate plane now. Let me see, Andrew, if this problem were about the area of a rectangle, it would not work. Why would it not work? Any thoughts on that? Why wouldn't that work if it were about the areas of rectangles? Say the length of the edging that surrounds a rectangular garden K is half the length of the edging that surrounds rectangular garden G. Any thoughts on that? Catherine's got it. Two variables. They're not necessarily, and Brooks is saying it yet another way, not necessarily similar in shape. You could have two rectangles in different shapes. What would work here? Follow on those thoughts. What would work better? A square would work better, because if you know the side of a square, you know its diagonal, you know its area. So if you have just one variable, or if you made the two rectangles similar, actually, I think if they were similar rectangles, you would still need to know, let's see, no, you would be able to do it if the two rectangles were similar. I'll have to think about that during, just to confirm that during while you're working on the next problem. But if they were similar, then you would be able to, you would get D here as well. And notice, any two circles are similar to each other. The ratio of any length here to any length there will be the same. The ratios would need to be the same, meaning that they're really the same shape. So what does that mean? That means that, say, this side is half of this side. The other rectangle would also have to have the same ratios, that the short side would be half of the long side. Your thoughts on that, Emily?
Yeah, I was just typing in about similar rectangles. I think if you had similar rectangles, it depends on what else they gave you. They'd either have to give you also the ratio of length to width for both of them, because if they didn't, you would have to know the area of one of them at least. I think you could possibly see a question where the answer is A, corresponding to the need for the area of one of those rectangles.
Yeah, it's an interesting problem when it becomes rectangles here. Squares, I'm certain you'd be able to do it, but you'd have to fix this ratio somehow. Cool, good extension of this problem. Okay, next problem. We've got 2 minutes. Coordinate plane, give it a shot. Go ahead. Okay, coordinate plane, everybody's favorite plane. Go ahead, put in your answers. Give you a little help here on the board. What is this thing? Text it in to everybody. What does this look like? Once we get it to y is greater than or equal 2/3 x plus 2, which is really algebraic manipulation. Yeah, it looks like a line, and in fact, y equals mx plus b. Catherine, can you jump on the mic and tell us what that means to you?
It's just essentially the definition of a line. So if you plug in different variables that work in that equation, those will indicate the points on a line.
Cool, let's start with the b part. What does b represent in general, and what's the value of b here? So y-intercept is what you put in. What does that mean? And in fact, b equals 2. What does that mean, Catherine?
It means that a point on the line would be when x equals 0 and y equals 2.
Yep, intercept means it hits, right? So when you plug in the value 0 here, then forget about the inequality for a second. We get y equals 2 because this 2/3 x thing cancels out. And what that means, when I think of the coordinate plane, I think of a line of soldiers lined up along the x-axis. And what soldiers do, they do what they're told. And what they're told to do is to move wherever this thing tells them. And the soldier who's at the origin, who's at 0, 0, is told, move to 2/3 times 0 plus 2, which means that that soldier moves to right there. So let me put a big old dot right there. And that's the handy thing, or one of the handy things, about this mx plus b form, is that the b tells us right away where the line crosses the y-axis. Now that line could look like this. It could look like, let me just move it around. It could look like this. It could look like this. How do we know which way it looks? Slope. Slope. What is the slope of this line, again ignoring the inequality part, just thinking about the equals part. 2/3. That is what is represented as m. And what does that mean? Brooks, what does slope mean to you?
For me, slope means like how many over and up, or the relationship or the movement up and down the from one point to another point along the line.
Yeah. The way I think of it is very similar to that. I think, okay, if I take this green dot and I move that green dot, let me see if I can do this here. If I take this green dot and I move it over to the right 1 unit, how far up or down do I have to move the dot to get back on the line? That's slope. So again, I'm already on the line. I move to the right horizontally 1 unit. And slope answers for me the question, how far up or down do I have to move to get that big green dot back on the line? So let me draw some lines and have you type into the, it is change in y over change in x. Indeed it is, Danielle. So the change in x here, when I think of moving this over just 1 unit, is 1. And then the change in y is how far up or down I move it. So let's get familiar with some slopes. Case 1, type in, what's the slope of this blue line here in the bottom left? What's the slope of this line right here? Type it in so everyone can see. Yep, cool, 0, because if I've got a big green burger dot that's sitting on it, move to the right, I don't have to move it up or down to get back on the slope, get back on the line. Okay, how about this slope right here? What do I know about that slope? From what you can see, and assume I've drawn this to scale. Positive. Yeah, I like that so far, because if I move to the right, if I move the green dot to the right, I got to move it up. And I don't have to move it up all that much, so I would say this is a pretty shallow slope. How about a slope of 1? What angle is that? Type it in. If the slope is positive 1, what angle am I forming with the x-axis? Good. 45 degrees. In other words, over 1 and up 1. Very good. How about the slope of this guy? What would that be about? Let's sort of estimate. Slope of number 4. Yeah, it looks about right. I'd agree with you, Andrew, that it's maybe 10 to 1. It's a very big number, because if I go over just 1 unit, I got to go up a lot of units. So this is a very large number. How about slope of number 5 there? Can't trick you all. Undefined. Vertical lines have undefined slope. The sort of problem breaks down. And then I go through the gamut. A steep slope that goes down is a big negative number, meaning like -10 or something like that. And then the shallower the slope, the closer to 0, and I get back to 0, back at 1 here. Undefined just means that the very the very way in which I define slope breaks down for this vertical guy. So if you call it the same as infinite, it's an open question what you would actually say. it's kind of funny because it approaches positive infinity as you tilt lines from this side, and then comes at you towards negative infinity if you come at it with steeper and steeper negative sloped lines. So I prefer to think of it as just simply undefined. If I move the green dot over to the right one, I simply can't get back on the line moving this green dot up and down. So the problem breaks down. So all that's to say, when I see 2/3 x plus 2 as my mx plus b form, that means I can just draw the line something like this. It slopes up to the right, kind of shallow, not fully at 45 degrees, and then y is larger than that. So that tells me, I'll stretch this out a little bit so we can see it. Y is larger than that, which tells me that possible points that satisfy the inequality are in quadrant 1, are also in quadrant 2, and they sneak into quadrant 3. So quadrant 4 is the only one that doesn't work. There are no points in quadrant 4 with a positive x and a negative y, which would satisfy this inequality. What that means, by the way, satisfying the inequality, is that if I plug in the x-coordinate and the y-coordinate there, I get a truth. And there's no way I can plug in a positive x and a negative y and get a number that's less than 0. However, for me, that's easy to see in hindsight. If I tried to do it that way, then I would get confused as I walked my way through the quadrants. Catherine, yes, if this were flipped around, if this were strictly less than, then it would still be E. The answer would still be E. But if this were flipped around, then every quadrant would have a point that satisfied the inequality. So it depends on which one you're indicating here. Okay. So what's the story here? Yes, the answer is E, because there is no point in this quadrant that is shaded in, and I'll change the colors up here to kind of this light blue. There are points in quadrants 1, 2, and 3 which satisfy the inequality, but the answer is E, because there's no point in quadrant 4. By the way some people try to attempt this problem right away is by just plugging points in, like 1, 1, 1, 2, and if you plug in, say, 1, 1, and you see it does not work, because actually 0.11, they were clever in choosing this particular inequality. 0.11, which is 1 up, 1 over, it's about where I've got my finger here, does not satisfy the inequality. However, that doesn't prove that there's no point in quadrant 1 that satisfies the inequality. So the point plugging method is only something you use as a last resort. You can solve it, but you'd have to find these points here, and then find these, and then find these. There are other ways to find this line, and one way to find the line quickly beyond this method is to find the two intercepts. And how do you find the intercepts? Plug in 0 for x and see what y is. Forgetting again about the inequality part, y would be 2. That gives us the green point here. Then if you plugged in y equals 0, you'd get the magenta point, x equals -3. However, that doesn't tell you which side to shade. And so then you'd have to test a third point, which would probably be the origin, to test whether or not 0, 0 fits. So there are other ways to solve this problem. However, I really like the slope-intercept form because that applies in many problems here. So again, just to show it, the slope-intercept form, be ready to do this math, isolating y, and don't forget, when you divide an inequality by a negative number to isolate this y, you flip around the inequality sign. And then y is greater than that red line as shown here, and so quadrant 4 has no shaded point. Yes, you can find other points for the inequality. That's true. Once you have a line, if you, say, found the green point and the magenta point by plugging in 0 for x and for y respectively, then all you'd need to do to find which side was shaded would be to plug one other point. And if you plugged in 0, 0, then you would get 2 times 0 minus 3 times 0. Is that less than negative 6? And the answer would be no. The point 0, 0, which I'll show here in this kind of beige orange, does not work. Does not work. So you could do this by plugging one other point into the inequality and just seeing whether or not it works. Okay, let's do one problem that requires 60 seconds and see how fast we can go on it. So the next problem you have 60 seconds on. Go ahead. Okay, awesome. I have near unanimity here. And as we saw in that first problem, we have parallel lines that we've marked with these arrows here. When we cut those parallel lines by a transversal, then the acute angles are all the same, the ones that are less than 90 degrees. And the obtuse angles are all equal, which means the ones that are bigger than 90. And when all is said and done, the deal is, you know one of these bad boys, you know them all. So each of these is sufficient. We'll do one more and then switch over. This is an advanced problem we're going to do right here. So again, the answer is D on this one. Here is the last geometry problem of the day. Number 164, almost at the end of the official guide. Here you go. Okay, keep working here as I reveal little bits and pieces. I will sort of move my pointer over things, drawn here. And type in for all to see, what principle should we use to rephrase further here? What principle should we use to rephrase this question? Equidistant is a fancy term for equally distant. I like it, Ganesh. My favorite Greek philosopher, Pythagoras. And we've got it twice. So we can rephrase further. Exactly. And then at that point, I'm pretty much leaving it. I want you to notice, at this point, once we have the question, is r squared plus s squared equal to u squared plus v squared, and we have these things, this is no longer a geometry question. We've done all the geometric translation from reading here, from drawing, from applying the Pythagorean theorem. We then have a purely algebraic question. Notice, by the way, c equals d, we can really rephrase that as c squared equals d squared, because we would technically be taking the square roots of both of these sides and then just squaring them. So technically the question would be, is the square root of r squared plus s squared equal to the square root of the other side? And then we just square both sides and we're all set. And all these c and d must be greater than or equal to 0, so we're fine. At this point, which statement should we start with? Once we're at a purely algebraic question here, which statement should we start with? Type it in. I agree. Tells us nothing. So that's insufficient. A, D, B, C, E. Cross out A, D. Now statement 2, what we have to do, and I'll just walk through this, is substitute and manipulate. So we plug this stuff in for U and for R. Oh, it actually, good question, Danielle. Doesn't matter where we choose to draw them. What do people think? Does it matter where we choose to draw them? Where we choose to draw UV, how we would express the distance? Yeah, it does not matter. It's absolutely right. We are looking for the absolute distance, and a distance is always 0 or greater. U itself, or V itself, or R itself, or S itself might be positive or negative, but when we square them in the Pythagorean theorem, it's not going to matter whether they were positive or negative. So however we draw them, it's just to give us a sense of where they live. It doesn't matter otherwise. So, good question. Now we have these guys, we sub them in for U and V, and now we're just off to the algebra races. Those are special products, the square of a difference. We should be able to write relatively quickly. Expanding each of those. And now combining up this minus 2r and this minus 2s term gives us minus 2 times the quantity r plus s. And the reason why that's useful is that we're kind of halfway thinking towards statement 1. This statement by itself doesn't get us down to r and s by themselves. And notice those r squareds and s squareds cancel pretty fast. We get those guys gone, these guys gone, and we get is 0 equal to 2 minus 2 times rs? Or we can actually rephrase this further. 0 equals 2 minus 2r plus s, question mark, 2r plus s. Does that equal 2, question mark? Does r plus s equal 1, question mark? And from statement 2 alone, that's not enough, but statement 1 and 2 together, it's enough. So this last problem here, notice they only go up to 173, so this is definitely a 700 plus level problem. It requires a pretty good chunk of algebra here with squaring up those differences and manipulating it down. And it also requires a fair bit of facility with the Pythagorean theorem in the coordinate plane. Distances in the coordinate plane will be the x-coordinate squared plus the y-coordinate squared if you're looking for distance from the origin, from 0, 0. If you're looking for distance between 2 points, then you take the difference of the x-coordinates and square it, and the difference of the y-coordinates and squaring it. I think you'd still have to, I'm being asked, would it work if we didn't use the Pythagorean theorem? At some point, you do have to use the Pythagorean theorem in order to talk about distance in the coordinate plane. Somewhere in there, this stuff has to come in. Okay, I just want to review, could you substitute numbers? It's kind of dangerous to substitute numbers in data sufficiency unless you are dealing with number properties. With algebraic and geometric problems, I think it's usually a dangerous thing, unless you're using those substitute numbers to figure out what's going on. So I would shy away from that. Yep, go ahead, Razi.
Yeah, and you just answered the question about the Pythagoras theorem. But if, for example, in this particular problem, we're given r plus s equals 1, and we determined that that statement was insufficient, and the second statement was insufficient. But since we're given an r plus s equals 1, and then in the other statement we have u equals 1 minus r and b equals 1 minus r, what we're trying to find out is if, like you said, the distance, we're trying to find the distance, so can we just like substitute what we're given in statement 2 into statement 1 and see if statement 1 works? And then that can determine whether or not C, which both statements together, works. Because we've eliminated A, we've eliminated B, now we can eliminate F, so that means that it eliminates D, so we need to find out if C works. If it doesn't, then it's E, right? Or am I just, it's just a really, it's asking for trouble.
Well, let me ask you, when you say substitute statement 2 into statement 1, I agree with you, we're at the point of deciding C or E. But what is the question that we're trying to answer? Notice, we are not ever able to solve for R, S, U, or V by themselves, according to this. We have some relationships among them, but we're never able to get numbers for R, S, U, or V. So when you say substitute this into this, I'm not sure what question you're trying to answer unless you've gotten it somehow to this. And tell me if I'm not answering your question.
I'm not sure if you are or you aren't, but I guess maybe the method that I use is that since we're given R and S, and we want to see if the distance across and up is the same as the distance across and up or across and down for U and B, what I basically did was I just substituted U to equal 1 minus R and B to equal 1 minus S. So since we're given R plus S equals 1, I just substituted R to 1 minus R plus 1 minus S and checked if that equals 1. And if that statement worked, then I'm basically told that U and B is the same distance that R and S are from the origin. I'm not sure if that makes sense.
No, I see what you're doing. Let me see if I can type it in. This is an important point. If I plug in, if I solve statement 2 for R, then I get R equals 1 minus U, correct? And if I solve this one for S, I get S equals 1 minus V. And if I plug those into statement 1, then I get 1 minus U plus 1 minus V equals 1. It doesn't turn into simply 1 equals 1, which is always true. I can't get rid of all the variables here. When I put them together, I don't simply get 1 equals 1. We can talk about this offline, but that's not actually, if I never have a question that I'm actually answering. Now it is true, yes, you can look at the two lines that get formed here and the points of intersection and decide that way. But I think that that's actually a much harder way to do it, because you have to make sure. Okay, so that's not what you did, but how do you substitute into this unless you have actually solved for R and for S? What are you actually doing, Razi?
You might have to type out exactly what I have on my piece of paper here. So the first step is we're given R plus S equals 1. So we want to find out if U, if it's the same distance, then U plus S should equal 1 too. So we're given in statement 2. All right. Okay. So that's where that's probably what it is then, because I just took it since U equals 1 minus R and V equals 1 minus R, then substituting 1 minus R into R plus substituting 1 minus S into S, and we have to see, and then I looked at whether or not that solution is, if we can still replicate that solution that's given in statement 1. But go ahead. Yeah, you're saying it's not true.
No, R plus S equals 1 does not imply that the point RS is 1 away from 0, or that U plus V should also be equal to 1. That's not necessarily the case. I think that the way that we're going here is pretty dangerous. What you want to do is always start with the question and rephrase it as far as possible. I absolutely believe this is the easier way than by sort of thinking of the lines in an abstract way and trying to get them to cross, partly because what winds up happening is you have to think of a lot of different variables on the same coordinate plane. If instead all you do is say, okay, how far is the point RS from the origin? Well, it's R squared plus S squared square rooted. That's what D is. How far is point UV from the origin? It's U squared plus V squared square rooted. That's what C would be. So then I just set, is C equal to D? I just ask that question, and then that means is, and we actually wrote this in reverse order, but it's the same thing, is U squared plus V squared, the distance C here happening to be squared, equal to the other two coordinates squared. And I honestly believe this is simpler. Let's debate this after class. I don't want to take more time on this question. It's a really good question though. So let me just quickly say, in review, remember, don't assume anything. Make sure you use all the information. Know your rules. In the process, diagram. No worries, Razi. It was, and others were asking similar questions, and I'll follow up afterwards. Make sure that you identify that wanted element and infer from the givens. As we just saw, actually, geometry problems are often algebra problems in disguise. They use geometry as a way to sort of disguise algebra, so work your way through that. I'm just going to take a couple of minutes to quickly boogie through some preparing to face the GMAT stuff we didn't get to last time, then we'll take a break. This will just take a couple of minutes. What I want to make sure that you're doing by this point is assessing your progress, and a couple of different ways to aspects of that process. One is that you're collecting data. You should have taken a couple of practice exams by now. You could also be tracking your work on OG problems using, say, for instance, our Excel sheet, the OG tracker. And don't forget your gut check. What do you feel good about? And that's really where the analysis comes in. So, of course, as you look at any data, look where you're wrong and slow in both content areas and question formats, but also just ask yourself where you feel weak, where you feel strong. Using the OG tracker, if you've been plugging in your answers, the OG tracker, for those of you who haven't been using it, is a pretty simple spreadsheet in the sense of it's not, it doesn't contain weird, complex formulas or anything, but you just plug in what your answer was on any OG problem and what your time was in seconds and any notes that you have. And over time, as you put in more data, you can check the stats pages to see how many you've gotten right of particular topics, what your average time is, and the payoff statistic is pretty handy because it tells you if you spend over the target time on that question type, do you tend to get it right or not? So a payoff of 100% would mean every time you went over time, you got it right. A payoff of 0 would mean every time you went over time, you got it wrong. So higher payoffs mean, yeah, it's probably worth it spending a little extra time in that area. A low payoff would mean cut your losses. Likewise, using the CAT tools, the CAT assessment reports tell you, for instance, in the quantitative areas, yeah, so where is this located? Do you mean the Excel tracker, the OG tracker? The spreadsheet. This guy is located in the course downloads page. That should be in your practice center. So when you go into the student center, look under course downloads and it will be in there. After you've taken a look, email me to let me know whether or not you've seen it. If you haven't, then we can communicate about that offline. The CAT assessment reports, after you've done a CAT, you can not only look at it problem by problem, but you can run those assessment reports. And these assessment reports bundle up one or more CATs for you. So you can see, for instance, here in geometry, you know what, I'm pretty low in accuracy and I'm pretty slow. I especially get stuck here. So I want to make sure that I spend some time working on geometry. Now, I've only just gotten into geometry, so thank you, Emily. I've only just gotten into geometry, so don't overstress if you've been behind in that area. That's fine. Do not worry so much about your overall score. Worry about relative performance and attack your weaknesses. So when you look at the CAT problems in order as you've gone through them, be sure to look at these times of early questions, because if you've been taking too long there, then what can happen is that you've got to rush here and notice the difficulty may drop as a result. And if you click on a problem name here, you can look at the actual results. Lastly, there is on the course downloads page a review sheet about how to review OG questions. At this point, people can feel like, oh, I need to go do more and more and more OG problems, but it's important to review them. And when you review them, in theory, you should be asking yourself these questions. So first, do I get it? Do I get what this question is about? Do I understand the content? How about my recognition? Was I able to, or am I able now to categorize this problem? Like what book and what chapter? Are there other problems I can think of that are like it? Then am I able to execute plan A, both to choose that plan A and to carry it out? How about plan B and C? How about guessing strategies and understanding the traps? So especially plan A, I should have straight. Plans B and C, I should be thinking about when I'm reviewing and understanding how the problem was constructed. And from the point of view of mastery, could I teach this problem? Do I feel so comfortable with this that I could present this to class? That's how you remember. So with that quick review of some review questions, let's take a 5-minute break. And when we come back, Emily will take us into the verbal section. Yep, I will leave this up. Absolutely. And also these questions are on a sheet that you can download in the course downloads page that Emily just posted, actually. Okay, we'll take 5 minutes at this point. And then I'll go back to the geo review. And topics and subtopics. Topics and subtopics are the titles of your chapters. That's really it.
All right, welcome back, folks. We're going to do strengthening and weakening the conclusion both today because obviously they're pretty related. They both have to do with what effect a new statement would have on the conclusion. So let's go back to our old building analogy for an argument, where the conclusion is like the roof of the building. There's really only one way to strengthen an argument, and that is to throw in another strengthening premise, something that wasn't already mentioned, a new supporting premise. The thing to note about this is that this will often be new information. So one common thing that I've observed people do is reject choices because they bring up new information. They say things like, well, that wasn't mentioned in the argument at all. Well, it may not be. Maybe it's mentioned in the choice because you need new information. This would be a great example of not eliminating choices just for that reason. To weaken an argument, there are two ways to do that. You can either add a countering premise, sort of like a negative point that you hadn't yet thought of. I think of those as the yeah, but premises. And the other way is to strike down an assumption upon which the argument relies. And I'll give you an example of both. Yes, so Catherine brings up drawing a conclusion. Remember we did that last week, where we didn't want to make any assumptions, we didn't want to use any new information, we just wanted to rely on what was in the paragraph. In this case, since we have a conclusion, it's fair game to choose a choice that adds new information that would support that conclusion. Yeah, new information is perfectly fine. Likewise, you might see new information when weakening the conclusion. In my example, that is certainly true. So my example is this. Chocolate has antioxidants in it. Therefore, you should eat chocolate every day if you want to maximize your health. A countering premise is something like this. Yeah, but chocolate has a lot of fat and sugar in it, and fat and sugar are not good for you. See, that doesn't completely destroy the conclusion. You might still decide to eat chocolate every day. I would. But the countering premise is there, adding new information that sort of counteracts the positive things stated in the argument already. To strike down an assumption in that one, you might attack the assumption that antioxidants are essential for optimal health. You might say something like this: other things besides antioxidants are more important than for maximizing health, or there are better sources for antioxidants if that's what you want. Something like that. If that makes sense so far, give me a smiley face and let me know if it doesn't. Yeah, if they're not so good, found elsewhere, greater concentrations or something like that. Okay, good. To that I will just sort of add this comment. Like if you're going to label something as a weakener with a W, in fact we're going to do that in just a minute, I'd call adding a countering premise a little w and striking down the assumption a big W. Because it's sort of like in our building. You could put something on the roof and not have it collapse, but if you dig out the foundation, the whole thing will collapse. And so on this question type, it is usually a good idea to read all 5 choices. I know on previous questions we've asserted that you might not want to go right into the choices. Certainly on reading comp, we recommended that you go back to the passage and find the answer there before allowing the question options to mislead you. But here, you'll often see questions where they ask you which most strengthens. In other words, they want you to compare the choices to one another. You have to look at all 5. So as you do so, just jot on your paper what your opinion of them is. So as you read A, think about how does it relate to the conclusion, and you'll form an opinion. It really strengthens or strengthens a little bit. Just jot down S's and W's as you go. So we recommend using a slash for anything that's not completely related to the conclusion. And note that on the GMAT, it has to be explicitly related to the conclusion, not just by assumption. for it to relate. If you're telling yourself a big story and it's kind of complicated, how the choice relates to the conclusion, it probably doesn't. Put a little slash next to it. Don't draw through the letter because you're not eliminating the choice or anything like that. You're just labeling it. Big S's, little s's, big W's, little w's. Now I want to hear what you guys think about this question. Type in for me, if you got this question phrased this way, what would you be looking for in the choices? If you were to rephrase this question, type it in. Yeah, you guys are too good. Your first reaction, though, wasn't it? Was to say, I'm looking for something that weakens. And then all of you said, why is she asking at me this? There is one third option, right? There's strengthen, there's weaken, and then there's do nothing options, the irrelevant ones. So on a question like this, you might see a chart on your paper like this, where there are 4 strengtheners and one that simply doesn't. If you're not aware of this little GMAT trick, you might say to yourself, well, I've missed something about these choices. None of these seem to weaken. And that can cause a little bit of a freak out, right? Like, what have I missed? No, don't worry about it. This is fine. You can pick C as the answer. None of the choices weaken. You're just looking for the one that doesn't strengthen. And here's how the GMAT thinks about this. If you drew a spectrum between weaken and strengthen and laid your choices out in the appropriate place. So we have 3 small S's, B, D, and E. We put them here. A is our strongest strengthener, and C is neutral. The one that strengthens except is the one furthest from S. All right, so you guys all nailed that. And that's going to be our approach. We're going to, normally you'd read the question first just to see that it is a strengthen or a weaken type. Those words will appear in the question. Tonight they'll all be that way. On this type of argument, I think it's probably the one that you can most safely avoid diagramming. I tend not to diagram on this type. As long as you are diligent about finding the right conclusion, that's essential. Diagramming beyond that, if you're not inclined to diagram, is probably reasonably safe. But even still, just a minimal diagram of like maybe the keywords in the premise might be helpful. So try that tonight, and definitely tonight I want you to set up an SW/ chart on your paper. In fact, I will ask you about your assessment for each of the choices on the upcoming question, so jot this down. Once that's on there, eliminate answers based on your chart. We're warning you to be careful about the wording, and just hop back here. I want to make one other comment about this little chart. You have extra assurance that C is the right answer because it's the one that's not like the others. It's the unique one, both in the way it's labeled and in the fact that it's right. So extra assurance from your chart. Eliminate your answers based on that. Choose the one that's unique, usually. Usually the one that's unique, but be careful in interpreting the wording. All right, let's begin. Oh, Danielle, does it mean that the answer choice is always in that order? I'm not sure I understand what you mean. Like, are you asking about this and how we're labeling them? Go ahead and grab the mic, Danielle.
Oh, hi, sorry. I just meant in that original chart where we said, like, A really strengthens, B weakens, C has no bearing. If I understand correctly, it's just that usually those options are there somewhere, but not in the not in that set order, like the way we have our, data sufficiency A, B, C, C, E.
Yeah, these are like all the other critical reasoning questions where you'll have, of course, 5 choices, there is nothing that we're trying to imply here about the order in which they might be presented. Like, if they rank them all the time from highest strengthening to most weakening, that would give away the answer in many cases, right? Because if you're going for most strengthened, you'd always pick A, and if you were going for most weakened, you'd always pick E. So yeah, they can be mixed in terms of order. Let me ask you, what would your answer be on this one? Everybody just poll it in. If you're looking for the most strengthening. In fact, I might have just given it away. But go ahead and ring that in there. They aren't ordered, but it does happen that A is the one that really strengthens here. So I made the point earlier that your choice might be the one that's not like the others. Maybe less so here, because we do have 2 choices that strengthen, and that can happen. Essentially, the toughest part of this question would be a judgment call between A and D. You might go back and read those 2 and decide which one truly does strengthen more. Whereas over here, we had a truly unique choice. C really stood out a little bit better. All right. Let's begin with this one. I'll give you guys 2 minutes. And pull in your answers with the buttons up top when you're done. But be prepared to give us your SW flash assessment of all 5 choices. Don't type them in just yet. I'll ask you for that in just a little bit. All right. I'll give you guys a few more seconds to get those answers in. I'm missing about 3 of them. And everybody else, start typing in your S's, your W's, your slashes for A through E. Separate them by commas or something, so I know which is which. And just send them to everybody. All right, this is great, and hopefully you are also looking at what your fellow students have typed in for their S's, W's, and slashes. From that, you can probably anticipate what everybody's answer is. You guys aren't in complete agreement, but you guys are all, many of you are drawn to C, which does happen to be the right answer. I won't leave you in suspense about that, but let's look at our SW flash charts, which you notice are differing, certainly on the other choices. Most of you, let's talk about the conclusion first. Andrew, would you grab the mic and talk about what you saw as the conclusion of this argument? And what did that imply about what you needed to look for in the choices and draw from the premises?
Well, the first thing I saw was be profitable. So therefore, obviously something about that. The other one I said was near Chicago, hence why I said weekend for D. But when I thought profitable, I thought the one line that was sort of going against that, or that needed to be, I guess, countered, was expenses, especially for electricity, are high. And so from there, anything that could negate that or make that seem not as high as it could be, or could be altered in some way or compensated, I thought would be the strongest answer.
Yeah, I think that's a great assessment. Our conclusion is that stuff highlighted in yellow in the question stem. All the more reason to begin by reading the question. The projection that is a big clue there. And it's all about profitability. It gives you a sense right away of what is going to matter. And this is one piece of outside knowledge that you are expected to have on the GMAT, the profit equation. So profit equals revenue minus cost. So Andrew's absolutely right to seize upon or pay special attention to this premise given up here that has to do with one piece of that equation. If expenses are high, that's kind of a negative. It is a negative for the Chicago facility. It tells you that if you want to strengthen this argument, you might want to hone in on something that sort of counteracts that. Yeah, but and Chris is bringing up a great point. Doesn't A have to do with cost as well? And almost all of you, in fact everybody who typed in, called A strengthener. So let's see, Catherine, would you grab the mic? Tell us why you labeled A strengthener but only a small s. And why did C warrant a big S?
Well, on A, it does address that once the operators of the facility are experienced, then the expenses will go down by 25%. The challenge is that since the question asked about profitability, it still states that relative to the washed spinach that is more typically produced, it's still 4 times as much, so you don't get to a point where you're competitive necessarily. Whereas C, okay. Should I get off the mic here?
Yeah, just one sec. I'm sorry to interrupt you on that, but you made such a good point about this 4 times as much. They even quantify how much more expensive it is. How might you test whether, Catherine, you said this is so much higher that a 25% reduction doesn't do much. Did you actually do any math with that, or could you?
I didn't do any math, but essentially 25% is 1/4 versus 4 times, so you're still not going to be competitive with the spinach that is typically produced or more commonly produced.
Yeah, absolutely. And sort of fractions, decimals, and percents from last week. Yeah, 1/4 of that 4 times is only going to be like 1 time. You could continue the math to realize that they're still going to be 3 times as expensive. You could also pick some smart numbers, but you were dead on with the instinct there. So ironically, it is the preciseness of this number that makes A less of a strengthener than C. Let me hop back. You were about to talk about C, Catherine, and tell us why you thought that was more of a strengthener.
So since profit is revenue less expenses, I think the key with C is that it states that you can sell it at an exceptionally high price to such customers as high food restaurants. So even though it wasn't precise, I think exceptionally meant that you could really charge a lot more, which would grow your revenues hopefully in excess of the 4 times that would cost relative to the more typical spinach that's sold.
All right. How you guys feeling about what Catherine just said? Smiley face if you agree. Thumbs down or frowny face if you're disagreeing or doubtful. All right, looks like you convinced them, Catherine, and C is the right answer for all of those reasons. I will say that sometimes people question C because they think there's room for doubt in it in a couple ways, right? Such customers as health food restaurants, people say, well, isn't that a very limited market? People sometimes doubt this word, that will sell. They say, well, that seems a little far-fetched. All of that is overthinking for GMAT purposes. If they tell you it will sell at exceptionally high prices, believe it. They even say in the question stem, which of the following is true, no matter how far-fetched it sounds to you. Likewise, such customers as health food restaurants, they're just given as an example. The market may, in fact, be limited to those health food restaurants, but profitable is profitable no matter how large the market is. So you guys were right to pick C. Let's look at the other choices. Why did you guys say that B was either unrelated or a weakener? Danielle, would you grab the mic and tell us why you thought B was unrelated? Maybe Danielle stepped away for a second. In fact, let me go back to Catherine. You're the one who called B a weakener. How so?
Where the words virtually no scope for any further reduction in cost. So I took that as there wasn't a way to reduce costs. So it didn't strengthen the argument, and it weakened the argument because it didn't bring in any information with regard to increasing revenue. So essentially it says that that nothing has changed. So I looked at it as a weakener.
So it sounds like you're saying that if it didn't strengthen or if it failed to really do anything, no reduction, well, that means no change, then it didn't strengthen, so it weakened. Danielle, I'll hop back to you. Looks like you're here. Why did you say it was unrelated altogether?
E being unrelated?
Nope, sorry about that. Talking about B. Choice B as in boy.
Okay, I did say it was, oh yeah, I did say it was unrelated. I said it's unrelated because I think that it's a little, I think it's irrelevant because whether or not California field spinach can get cheaper, it just doesn't really affect why. It doesn't affect the conclusion that the Chicago facility would be profitable.
Yes, yeah. So there is something to keep track of here. I think it's deliberate that they picked Chicago and California that both begin with C's. I find it's difficult to keep them straight here. And the other thing that's tough is they talk about both facilities both ways. They talk about them by the name of their location, but also the type of growing they do. Field spinach is used to refer to California. Facility used to refer to Chicago. Yeah, so that's the kind of stuff I would write down just so I know what's what. And Danielle, you nailed it. If they don't make an explicit connection between the cost of California field spinach and what happens to the business model of Chicago spinach, there is no relationship. Even though, you know, from your outside knowledge, you may know that your competitors' pricing schemes or their cost structure is something that you can factor into your business model. It's too much thinking for the GMAT. And for that reason, D and E are both irrelevant as well. A lot of you pinpointed this. I'll just quickly point out that D talks about shipping and the market. But what it says about the market for them is that they're the same. So in other words, it doesn't really change this argument. The relative expense structure is still the same. And it fails to give us anything that is positive or counteracts the negatives about Chicago spinach. And E, second facility in Canada, is completely unrelated by GMAT standards. In real life, we might take it as an example, right, that the business model will work, but you can't do that here. Any questions on this one or further comments? Yep, the devil is in the details on these, but nice job on that one, guys. Let's move to the next one. I'm going to have you guys do something a little bit different. I asserted earlier that you're going to have to look at all 5 choices on these and sort of weigh them against each other and not so much anticipate the possible answers. I'm going to completely contradict myself here and have you guys think about some possible weakening statements for this argument. And I'll just release the mic. Anyone can grab the mic and throw one out there.
I was just going to say the newspapers sold in Town S don't have any information of world events that are going on.
All right, good one. And John Laurent typed that one in as well. So Ryan's typed in another one in about where people buy the papers. I'll release the mic again. Any others that you guys can think of? All right, I'm interested in this one. Brooks and Amit, you're both talking about the number of people. Amit, why do you assert that the number of people matters? Go ahead and grab the mic.
Yeah, I mean, if there are more number of papers sold in town as it's not necessary that everybody are everybody needs to be better informed there. It's just because it might have more people over there, so that's what I meant. So better informed is kind of misleading there.
Brooks, you want to add to that?
Yeah, what I was thinking was that even though there's more sold in Town S, it might be a smaller percentage of the populace than in Town T. So, like, you could have everybody in Town T reading a newspaper, but if Town S is 10 times bigger, it'd be a smaller percentage. It doesn't mean the entire population is necessarily smarter.
Yeah, I think that's a good point. You could have 2 towns with the same percentage of readers, and the larger town would simply sell more papers, or there would be more papers sold, without it being possible to assume that one town is more informed than the others. Well put. All right, have I missed anything? Yeah, Town T, a couple of you, Catherine and Andrew, are suggesting, well, maybe Town T people get their major world events knowledge from other sources. So you can't assume just because there are fewer papers, they are not well informed. Let me make sure. Have I missed anything? Let me know if I have. Alrighty, well, with that in mind, this was a pretty weak argument, and that may be why they are phrasing it this way. Each of the following weakens the conclusion, except. So when we see 5 choices, we're going to see a lot of weakeners among them. Here are your 5 choices. Go ahead and pick your answer. I gave you guys abbreviated time on this one since we had already talked about it a little bit. I'll give you a little bit more time and remind those of you who have answers in, we're looking for the one that doesn't weaken. So you should eliminate the 4 that do. 30 more seconds. All right, last call on answers here. And let me hear from you in the chat window. Everybody just type in, are there choices up here that you recognize from our little brainstorm earlier? Which of these correspond to the things we thought of as possible weakeners? Any of them ring true to you? Go ahead and type in if you saw them here. All right, so you guys are seeing A and B as things that we came up with. I agree. We discussed the population implications at some length, and we talked about where people buy their papers. Maybe some of the papers sold in S are purchased by people in Town T. I'm going to hop back here and point you to this one. This was the very first one that you guys came up with. Town S papers cover local news only, no world events. So you guys were interested in the content of the papers. Very good point here, right? Since the conclusion is about something very specific, informed about a very certain thing, major world events. Which choice up here most relates to that suggestion? Yeah, Andrew. So, and Ravi, you're saying D relates. Now, how come nobody typed that in when I said, which one of these did we come up with? Andrew, why do you think that is?
I'm guessing it could be one of two reasons. The one is that it's lower down, so we've forgotten about it. The second is that the location of where that information comes sort of came at the end of it, as opposed to the beginning, which says a weekly newspaper. Those are my two thoughts.
Yeah, I think you might be on to something, especially about this part about the weekly newspaper. Did anybody pause over this? Just smile if you're sort of thinking along the lines of Andrew's suggestion here, that maybe people didn't view this as so much of a weakener because this sort of seems to mitigate it. Well, it's only a weekly paper, and there may still be daily papers, so maybe it doesn't weaken. Smile if you kind of thought about it that way. Or isn't D relevant? Why do you think D's are relevant, Danielle, altogether?
Because the fact that there is, restricted, that there is something that only covers local events doesn't have anything, doesn't take away from, doesn't add or take away from the conclusion that we're talking about.
Okay, so you're sort of viewing this weekly paper as like on top of the newspapers that were, in addition to the newspapers that are mentioned up in the argument, there's this other weekly paper. And I bet you're not alone there. Here's the GMAT insight. There's nothing here actually telling us, though, that this weekly newspaper is an addition. So it's at least possible that some of the newspapers mentioned up here in the sales statistics are in fact these weekly newspapers. And the fact that this could even possibly weaken means that this one is altogether a weakener. Okay? Chris is drawing something out. I think he has a visual for this. I'll let him grab the mic.
Yep, I had someone go to the mat in one of my classes on D. She was arguing that because this answer choice only talks about Town S, how could it have anything to do with a comparison between Town S and Town T? And one way to see it is to put the newspaper sales on a graph. Plus is published, not sold. Yeah, there are several things that are a little hairy about it. Remember, though, that weakeners don't have to disprove the conclusion. They just have to sort of help create a reasonable doubt. And the evidence cited in the argument is that this number is bigger than that number in terms of sales of newspapers, and so therefore citizens of Town S are better informed. Anything we do to sort of attack this number as being sort of not so relevant, then what we're doing is weakening the argument. So, kind of in the same way that A and B sort of attack this number as either not the right metric, you should do it on a per capita basis, or that some of these papers are actually bought by out-of-towners. D is saying, well, there's reason to believe that at least some of those papers don't actually deal with world events. Doesn't say, how many of them. It could be just a couple of those newspapers. But there's good reason to believe that at least some of those newspapers are just local papers, and that's only going to bring this number down. It can't bring that number up. So I hope that's helpful.
Yeah, at this point I'm going to show the answer choices just to show how split we were on this. Even though you guys were all in agreement about things that could weaken, and we have choices that pretty closely matched what we came up with. The biggest difference between the answers you all anticipated and the ones that are up here is that this has GMAT fuzziness in it. All the choices here. For example, in C, there's something similar going on. They talk about the citizen of town as spending less time reading. We didn't come up with it, but we might have typed something like this. Town S people buy papers, but don't read them. Because obviously you don't get informed by just buying a paper, you get informed by reading it. And some of you were onto this a little bit, I think, by addressing the Town T people. Maybe they read something they don't buy. These are sort of related ideas. But the GMAT kind of hedges that and says, oh, spends less time reading, rather than saying doesn't read at all. Yeah. So it's not as absolute, but it's still a weakener. So actually, A, B, and C all weaken. The correct answer is E. Ryan, you picked E. What does E actually do?
It doesn't strengthen the conclusion.
So you picked it because it doesn't weaken, and you're saying it doesn't strengthen. Does it relate to the argument at all?
No, it really doesn't relate to the argument at all. So since I had 4 weakens already, it was kind of like the neutral one, so I thought it was the strongest choice.
Now, Ryan is absolutely right. The newsstand price has actually no relation to the conclusion, which is the people are better informed in S. Sometimes people will see a connection between these two because it is plausible that lower price in S affects what? Go ahead and just type it in. Yeah, the old price-demand relationship. And as John Laurent's pointing out, that has to do with readership as well, right? So you could sort of do a cause and effect here, like lower prices in S could lead to more papers sold, which is something we're told is true, and therefore people are better informed in S. But Ryan's point is a good one. It doesn't directly link the lower price in S to how informed people are. This was a pretty weak argument to begin with, and the big problem was that the premise was not well linked to the conclusion. So by strengthening maybe the premise here, you're not doing much for the conclusion. So great, E is the right answer. Let's just move on. I'll let Chris handle remaining questions there. I'm going to put up a review slide. If you've got questions for me, let me know. Just remember that when we strengthen, we're going to look for a supporting premise. Weakening, we do by countering a premise or attacking an assumption. I'm going to hop back. Catherine, I just saw your question come in about choice B. Now, B has to do with sales as well. Is that why you're saying they're the same? You want to grab the mic?
Yeah, they just seem to have similar relativity in terms of papers sold, and then better informed to me.
I think the big difference between these two is that if you take the price and sales as related, the very most you can hope for from E is that it strengthens the premise. But we're already relying on the premise that more papers are sold. So it doesn't add anything to this argument at all, right? We are still assuming that there are more papers already given. What B does, even though it has to do with number of papers sold in S, it more directly attacks an assumption that links the premise to the conclusion. The assumption is about who's actually buying the papers. It suggests that the people buying the papers in S are not who we think they are. So it weakens really well by directly sort of severing this arrow between papers sold in S and how informed S townspeople are. Yeah, at this point I'm going to suggest that we move on because we do have to cover sentence correction, and I agree with Chris. This is a good one to go back over. Maybe we'll put it up in a review next week. We do have some time for that type of thing. Or to just pop it up in the recording and look at it again. Alrighty, got to cover comparisons relatively quickly, so I'm going to keep this moving. Comparisons are like parallelism light. It is parallelism usually between two things. So let's lead with a question. I'll give you guys a minute 15. Alrighty, got a clean sweep on E, which is the correct answer. Rosie, would you grab the mic and tell us why E is correct?
I looked at the sentence as a whole, and I actually dropped off the modifier, which requires a 15 to 20% down payment, just looked at it as extra, and just reread the question as unlike a typical loan, and looked at the answer choices. So there was with lease loan buying, lease loan buyers, for the lease loan buyer, and a lease loan does not require. I felt E, in that sense, kind of, there was a little bit more parallelisms, and unlike a typical automobile loan, a lease loan does not require the buyer to make an initial deposit on the new vehicle. With the other four choices, it's just the sentence just does not work without the modifier.
Excellent work on that one, and I really like that you pointed out the modifier, the middleman here. We've seen this before in subject-verb pairings, the middleman in the way. They do that on comparisons as well to throw you off of what is a fairly straightforward topic. You got to compare apples to apples. You got to compare a loan to another loan, and that phrase is there to distract you. Don't let them play that game with you. So the problem with all the other choices is that it's the wrong noun. We're looking for a least loan and only E has it. So that's parallelism in a nutshell. You will see a comparison signal word, the unlike in this case, and you'll have two sentence elements, the things that are compared. And it's typical on the GMAT to see one of those in the non-underlying portion and the other that you have to choose in the underlying portion. There are questions where both parts appear in the underlying portion, but you would just have to make the connection and check all the splits the same way. So we picked E because it has the right noun. There's minor splits here between there is no requirement of versus does not require. You have the more active form does not require versus putting it in a predicate with there is. The GMAT definitely prefers this as well, but minor split in comparison. That's our basic principle. So once we spot that key word, there are two things we check. And this is almost exactly what we did last time that we talked about parallelism. One of the things we checked was that the two parts have to be logically comparable. This is where reading quickly and sort of getting what they mean might make you miss stuff. Frank's built like his brother is broad. You read that, you probably have a mental picture of the two guys, and you can imagine them being similar in build. But this is technically not correct because we are comparing Frank's build to his brother himself. Okay? Can't compare a build to a brother. So there's a couple ways to fix that. You can compare the builds to one another. Frank's build like that of his brother, throwing in that to represent build. Plain old pronoun usage is a common GMAT thing to fix a comparison problem. Or you could say Frank's build like his brother's, where the build is implied by that second possessive. You could even say Frank, like his brother, has a broad build, and just compare the two men correctly. The second thing that we check for is structurally comparable, or structural comparability, I should say. In this sentence, more thans are signal words, and it's not such a problem that we say I like and I enjoy, and they're two different words that mean roughly the same thing. That's not that big of a deal. The big problem is that to run doesn't match walking. So you'd fix that by just making them the same form as this sentence does, running and walking. And you get the added benefit of being able to use I like for both endings. I like running, I like walking. Smiley face at me if this is making sense. Let me know if it doesn't. So I think it's really here that the GMAT will try to mislead you. Structural comparability looks the same, so it's easier to spot. Just bear in mind that the GMAT will try to get you to think they're comparing apples to apples when they're really comparing apples to flavors of apples or apples to colors of apples. It's in the ballpark, but not quite the same. So some common signals are the like and unlikes. And usually the GMAT will put those at the beginning of the sentence just because it's easier to use them correctly there. You have your uneven comparisons, your more thans, your less thans, as taller thans, etc. And then you have your even comparisons, as, adjective as tall as loud as, whatever. You can compare actions by using as well. And here's one, different from. Sort of breaks from the uneven comparison convention where we use than. You can use different than. We'll talk about that next week when we do idioms, but usually different from is the preferred idiom. What they all require is parallelism between x and y. Take a look at this one. Give me your answers in 115. All right, let's call for answers on this one. Pick your best option. All right, Brooks, I'm going to call on you. What do you think is compared here?
I guess the comparison here is the way the Brontes and Brownings are venerated, or that veneration. And I don't know how to articulate any better than just to sort of say that want the Brontes and the Brownings to be venerated and express that in some way as it is expressed with Joyce and Virginia Woolf.
Yeah, and I like reading these for meaning that way because you have to say something that makes sense, right, and then figure out which way can you phrase it that makes that meaning clear. Would you guys all agree, just by smiley face or a thumbs down, that this is sort of what they're trying to say? This set of authors is venerated, so are these guys. Yeah, so Brooks, back to you. Which choice, how did that influence which choice you picked? Why did you think one of these got this meaning across better than the others?
I picked E because I thought some of the answer choices just kind of struck me as wordy. I mean, I liked the first one as far as meaning, but the fact that veneration was being connected to Joyce and Woolf, and we're using other words to connect to Bronte and Browning, seemed kind of confusing, and it was unclear to me exactly what the connection or the simile was that was being made. And by taking it out and just making it simple, like an E, it made it very clear to me that there was a direct connection to veneration.
Yeah, E is the right choice here because it very clearly links the two types of people. And there is a rule about like versus as, which is an important split on this. I'll show you that rule in just a second. But if you're saying the same thing about both sets of people, the most efficient way to make this comparison is just to say the people were like each other in some respect, and only say what that respect was once. So the later part of this sentence are often subjected to the same kind of veneration. In choice E, we're saying Brontes and Brownings are subject to the same kind of veneration. We're also saying the same thing about James Joyce and Virginia Woolf. It's a straight-up noun comparison. Authors are like authors. Smile if you're okay with that. We'll look closer at why the others are wrong, grammatically speaking, in just a minute. Let me show you the rule, because it's kind of unfair to throw this one at you without a rule in mind. And Ganesh, I see you frowning. This rule might help you understand this question a little bit better. We use like and as probably in speech a little bit interchangeably. I hear this error on TV a lot now that I know what the rule is, and I know that I probably make this mistake myself. On the GMAT, though, they're really picky about like is used to compare nouns only, and as is what you use when you compare actions. A clause is something with a verb in it. So, in this case, hop back to the idolization of the Brontes and the Brownings. We have a like versus as split. I'm going to move to a slide that sort of highlights this. One thing to note about like is if it's going to compare nouns, it's got to compare nouns that match, right? Don't be fooled by the fact that Brontes and Brownings precede the comma and are right next to James Joyce and Virginia Woolf in the original sentence. Because as Rossi showed us on the previous question, there'll sometimes be middleman that's misleading. And we have one here. Accorded the Brontes and Brownings describes the idolization, and it's the idolization that's the noun. So this is a wrong comparison between something and some people. Smile if you see that. And let me know if you don't. Okay, so we were using like to compare nouns, but the nouns didn't match. And that's what we're highlighting here. The idolization is the noun. In B, we have the idolization again, but this time we use the word as. And as demands that we are comparing actions. You can't use as correctly without using two verbs. There needs to be a verb in this choice. So B is wrong because missing a verb. And in C, we're back to a noun comparison, but again, we're saying like that, the people. It's unclear, for one thing, what that even means, but it's certainly not a type of person. It's certainly not the Brontes and the Brownings. So C is out because wrong noun compared to wrong noun. D has as used with a verb. That's good at least, but the it is ambiguous. And so we're down to E, which has the right comparison. So some of you were drawn to A and C. You were drawn to choices that use like, but be careful that you're comparing the right noun to the right noun. Now that you see it, let me know if that makes sense to you. Frown if you're still unclear about it. All right, cool. And just one more little exercise for you guys on this like versus as business. Here are a set of statements, and they all are intended to imply the same meaning. One of them is incorrect. In fact, in the interest of time, I'm showing the answers here, so I won't make you guys do this. But I'll point out that the one that is incorrect is 3 here. By saying a stucco house like Mary, there's a possible weird meaning, right? It's that Mary is like a house. I said earlier that you'll typically see on GMAT questions a like towards the beginning. Since it is a noun comparison word, you can follow like noun modifier rules where they need to touch. Joe like Mary. Very clearly a connection between those two. We're saying the same thing about those people. You can get away with a like at the end of the sentence, so it's less common on this test. By putting a comma there, it's sort of the signal that we don't intend to say the house is like Mary. The GMAT, though, I think would probably put it like this. Like Mary, Joe lives in a stucco house, putting the like at the beginning. This works because Mary's possessive. It's that possessed noun, house, that is compared to Joe's house. And here we see as used correctly. One thing I check when you see an as is whether you've got a verb there, and this one does. So here's a question for you guys. Between 6, 7, 8, which one of those is incorrect? Type it in. All right, Andrew and Angela, type on in a response there. Yeah, Chris was trying to trick you a little bit by asking which ones are incorrect. It is, in fact, only 6 that is incorrect. And the problem is not necessarily that it's a like used towards the end, but you can't use like with an is. There should be no verb there. So counting the verbs works really well. For me, yeah, it snagged Rousey on that one. Like swimming is, skiing is. And to answer your question, Andrew, if it were as, yes, it would be correct. As swimming is, nicely parallels as skiing is. And that's in fact what we see in 7, just with the order reversed, just as swimming, skiing is. So as is used correctly there with 2 verbs. And in 8, I think this is maybe where a couple of you got snagged. Swimming and skiing, remember those are treated as nouns. Those are gerunds. So there is only one verb here, and it is. So like swimming, skiing, that's an appropriate noun comparison. Yeah. And Danielle, your other question about 6. Yeah, it would be correct to use like. Skiing is a great way to burn calories, comma, like swimming. If there were no is, you could get away with that. But 8 would still be better. I agree with Chris. Putting it at the beginning is a better form. Less chance of ambiguity. There's another way that like gets tested, and we'll close with this and only possibly one more. Alrighty, last call for answers on this one. And John Laurent, I know you don't have a mic, but what did you see like being tested against? What is the split around like this time? Go ahead and type that in. And in fact, since I'm asking for typed feedback, Jean Laurent, you're typing. And I'll tell you your choice was right. Finance and marketing, like finance and marketing, or like those areas. So what did you see about that that you didn't like? A is something you avoided, and why? I'll throw that open to the group. A lot of you steered clear of A. Anybody see a problem with that? So Daniel's citing the those of as ambiguous, awkward, what? Go ahead and elaborate on that. Andrew's citing like versus have. Maybe over here. Like those of is awkward, prepositional phrase. Nope, nope, nope. You guys are dancing around it a little bit. Notice what we have in all of the choices. We have the specialized areas in every choice, followed by like or as. But here it's not just an as, it's a such as. And it turns out that's the split here. We'll talk about those of in just a moment. Let's look at that first sentence broken down. Students majoring in specialized areas like those of finance and marketing. Those of is not bad here because those appropriately refers to specialized areas. It's plural, just like these. So areas to areas comparison, right? But why is that still awkward? Why would we want to use like or such as? Anybody think of what a rule would be? Danielle, what do you think?
Well, I like what goes with nouns, right? So it would be in the those of is sort of strange. I would assume it would have to be like finance and marketing, but I chose an answer that used as. So I don't think it really follows the rule.
Yeah, and I think this might be an example of your ear rejecting something that is right by GMAT standards, but we would say differently. If I were giving examples of specialized areas that students major in, I would say, oh, the areas, oh, like finance and marketing, and throw those out as examples. What your ear is rebelling against here is that though they are using like to compare nouns here, you're saying, well, the those of sounds weird. But this is technically the grammatically correct way to compare these two types of areas. The problem is we don't want to compare areas, specialized areas, to finance and marketing. We want to name finance and marketing as examples of the areas that the students major in. And for listing examples, we want to use such as. Okay, so this is different. It's not quite a like versus as split. It's like versus such as. And that has to do with whether you want to compare versus whether you want to give examples. Yeah, the like versus as split, Danielle's asking about this distinction. Like versus as is a matter of what you're trying to compare, but both are used for comparisons, right? Like for nouns, as for clauses. If you say a split between like and such as, it's something different. Like is a noun comparison still, but such as is used for yet another purpose. It's used for illustrating examples. And let me show you some quick examples. Like means similar to, and according to the GMAT, that's the only role it should play. In everyday life, we might say things like this. I enjoy sports like baseball and tennis, and we mean these are two sports that we like. The GMAT views that as ambiguous because it could mean that I don't like baseball and tennis. I enjoy badminton and cricket. Those are sports that are like baseball and tennis. So their take on this is if it's an example, you use such as. And you can even separate the such as with another word, sports in this case, because that's the type of example we're listing. Give me a smiley face if this is making sense. All right, and when we hop back here, you'll see that's what they're doing to us. You just simply have to ask yourself in a split like this, are finance and marketing an example, or are we comparing them to something? We're not really comparing them, so we can get rid of A and D. Go with such as. I'll cut to the chase on this one because most of you did pick the correct choice from there. B is the choice that works. We have such as. We also have the correct tense. Who major makes better sense than who majored. Past tense majored means they're not students anymore, they're alumni. So we can decide based on that. We can cross out C for verb tense error. There's also an idiom. Becoming more and more is preferred to being increasingly. So that's a reason that we can get rid of E. Likewise, E has a strange tense of having majored, and there's no call for that one. So B is right. Yeah, more and more is actually the preferred idiom. Very, very unusual, right? It's kind of lengthy, but becoming less and less would also be the same thing. I think we're going to end there since I've kept you late again. But next week's our last week. So Chris, I don't know if you want to give them a heads up about anything they should prepare. I'll let you grab the mic. Oops.
Nope, nothing particular. Take a look at your syllabus, and again, as you go, we've now finished up a lot of the quote-unquote material in terms of topics, both on math and verbal, although we do have some odds and ends to wrap up next week. As you go through remaining OG problems, do start to review older OG problems and make sure that you have taken a look at those mastery questions to make sure that you've gotten them down. Next week we're going to spend some time talking about preparing for the GMAT from here on out. So be ready with your questions on process, et cetera, and see you in a week.